Okay, fun with ballistics. We have a projectile, and before we dive in, they note here all these questions are intended to be completed algebraically, which means don't worry about the calculator. The height of a projectile is defined by this. It's a parabola opening down, which makes sense. It means our projectile is going to fly like that and eventually thump into the ground. Complete the square to get this into standard form, they say. So our height is minus 4t squared plus 48t plus 3. There's a coefficient on the square terms, so we factor that out first of all. We get the height is minus 4t squared divided by minus 4, 48t divided by negative 4. Leave some room, and there's our plus 3. Now, take the minus 12, cut it in half, that's minus 6, square it, and you get plus 36. And then out here, because inside we have minus 4 times 36, here we have minus 4 times minus 36. So that this and this in red cancel each other out. Now we just try to clean that up. Minus 4, this factors, always does. It gives us t minus 6 all squared. And then we have plus 3 plus 144. So our finished version is the height is minus 4 t minus 6 all squared plus 147. Find the height 3 seconds after launch. All they're telling us there is the time is 3. Find h. You could plug 3 into here, or you could plug 3 into this expression. It doesn't matter. I'll use the original. Minus 4 times 3 squared plus 48 times 3 plus 3. 3 squared is 9 times negative 4 is negative 36. 3 times 48 is 144. Plus 3, that should be 111 meters. Find the maximum height. Guess what? We have already. This tells us the location of the vertex. The vertex is at 6, 147, which is right there. That is our highest point. These two numbers are telling us the highest point happens at 6 seconds, and the highest point is 147 meters up. So how many seconds after launch is maximum height reached? At t equals 6, because that's the location of this highest point when the time is 6 seconds. What was the height of the projectile at launch? At the launch. At launch, meaning just when the engine fires or just when this projectile is shot, nothing's happened yet, so there is no time, meaning we can plug 0 into this expression. We get minus 4t squared plus 48t plus 3, which is 0 plus 0 plus 3 is 3 meters. In other words, that's the y-intercept for this function, and it tells us where were we at the very beginning. And last thing, determine when the projectile hits the ground to the nearest tenth of a second. Well, what we want here is when is the height equal to 0. When you hit the ground, it means you've run out of height. So that would mean our height is minus 4t minus 6 all squared plus 147. We want that to equal 0. 0 height means you're on the ground. And now we have to solve this. So we take the 147 over to the right-hand side. It becomes negative. Divide both sides by negative 4. Oh, let's see. 35, 36.75. Is what happens when you divide 147 by 4. Now we square root both sides, and we get t minus 6 equals plus or minus the square root of 3675. It's going to be just barely over 6, 6.06. And then we add 6 to each side, and we get 6 plus or minus 12.0. I'm sorry, 6.06. Getting ahead of myself. So, two possible solutions. 6 plus 606 makes 12.06 seconds, or 6 minus 6.06, which makes minus 0.06 seconds. Do those both make sense? Our projectile goes like this. The 12 seconds certainly does. That means this object has a 12-second flight time and then it thumps into the ground. The slight negative value is back here. The math doesn't know that this object was launched at 0 seconds. As far as it knows, the object has been following this trajectory forever, and so, yeah, it stands to reason that a little bit before 0, this object should have been at 0 height. It had enough time to get up to 3 meters in time for the launch, and then it continued on, hitting the ground again at 12 seconds. So realistically, this didn't happen because the object was sitting still before it was launched. But that number does make a certain weird sort of sense, and the 12.06 seconds definitely works.